Hello viewers of AraaTech. Once again, as usual, we are presenting a new topic, models in artificial intelligence. Let's start. Understanding models in artificial intelligence. Definition. In artificial intelligence, a model serves as a blueprint or structure that processes input data to make informed predictions or decisions. It encapsulates patterns and relationships within the data, enabling machines to mimic human-like cognitive functions. Everyday life examples. Spam email filter model. The spam email filter is a classic example of an artificial intelligence model. It learns patterns from your email history, such as common keywords, sender addresses, and email structures. Functionality. Based on these learned patterns, the model predicts whether an incoming email is spam or not. Example, if the model detects emails containing words like free, discount, or from unrecognized senders, it may classify them as spam and move them to a separate folder. Recommendation systems model. Recommendation systems in streaming platforms or e-commerce websites use models to analyze your past behavior, such as movies watched or products purchased. Functionality. These models learn your preferences and interests to suggest content or products that you are likely to enjoy. Example, if you frequently watch action movies on a streaming platform, the recommendation model might suggest similar action-packed films or TV shows. Predictive text input model. Your smartphone's keyboard uses predictive text input models. These models learn from your typing habits and commonly used phrases. Functionality. As you type, the model predicts the next word based on context and your historical usage. Example, if you start typing I am going to the model might predict store or park based on your previous sentences or common phrases. Traffic prediction model. Traffic prediction models analyze historical traffic data, weather conditions, and events to forecast traffic patterns. Functionality. By learning from past traffic congestion and relevant factors, these models predict future traffic conditions for specific routes. Example, a navigation app uses these predictions to recommend the best routes to avoid traffic jams, helping you reach your destination faster. Medical diagnosis model. AI models in healthcare analyze patient data such as symptoms, medical history, and test results. Functionality. By learning from a vast amount of medical data, these models assist doctors in diagnosing diseases and recommending treatment plans. Example, a diagnostic model trained on X-ray images can detect abnormalities indicative of certain diseases, aiding radiologists in accurate diagnosis and timely intervention. In each of these examples, the artificial intelligence model learns from data to perform tasks that mimic human cognitive functions such as classification, prediction, or recommendation. This demonstrates how models in artificial intelligence play a crucial role in various aspects of our daily lives, enhancing efficiency and providing valuable insights. Data collection. Definition. This stage involves gathering relevant data that the model will learn from. The data could be in various formats such as images, text, or numerical values. Everyday life example. Suppose you are building a model to predict housing prices. You would collect data such as square footage, number of bedrooms, location, and selling prices of houses in a given area. Pre-processing. Definition. Raw data often requires cleaning and pre-processing to ensure its quality and suitability for the model. This step involves removing noise, handling missing values, and transforming data into a format suitable for analysis. Everyday life example. In your housing price prediction model, you might encounter missing values for certain features like the number of bathrooms. Pre-processing involves deciding how to handle these missing values, either by filling them with averages or removing them entirely. Model selection definition. Based on the problem and data characteristics, a suitable model architecture is chosen. This could be a neural network, decision tree, sport vector machine, or other algorithms. Everyday life example. For the housing price prediction model, you might choose a regression algorithm such as linear regression or a decision tree regression, as it's well suited for predicting continuous values like house prices. Training definition. The selected model is trained using the prepared data. During training, the model adjusts its parameters iteratively to minimize the difference between its predictions and the actual target values in the training data. Everyday life example. In training your housing price prediction model, you feed it with the historical data you collected. The model learns from this data, adjusting its internal parameters to improve its predictions over time. Validation definition. After training, the model's performance is evaluated using a separate validation dataset. This ensures that the model generalizes well to unseen data and does not memorize the training data. Everyday life example. You split your dataset into training and validation sets. The model is trained on the training set and evaluated on the validation set to check if it's performing well and not just memorizing the training data. Testing and deployment definition. Once validated, the model is tested on a completely separate test dataset to assess its real-world performance. If satisfactory, the model is deployed for use in production environments. Everyday life example. Finally, you test your housing price prediction model on a set of data it has never seen before. If it performs well and meets your criteria for accuracy, you deploy it for use in predicting house prices for new listings. In summary, the process of how a model works involves several iterative steps, from data collection and pre-processing to model selection, training, validation, and deployment. Each step is crucial in ensuring that the model learns from data effectively and performs well in real-world scenarios. Automation example. Image recognition. How it helps models automate repetitive tasks like image classification, reducing the need for manual sorting. Everyday life example. In security systems, artificial intelligence powered cameras can automatically identify and classify objects or people, alerting security personnel only when necessary instead of requiring constant monitoring. Decision support example. Financial risk analysis. How it helps models analyze large datasets to provide insights and support decision-making processes. Everyday life example. Banks and financial institutions use artificial intelligence models to assess the credit risk of loan applicants by analyzing their financial history, helping in making informed decisions on loan approvals. Prediction and forecasting example. Stock market prediction. How it helps models predict future trends based on historical data, helping businesses anticipate market changes and make informed investment decisions. Everyday life example. Investors use artificial intelligence powered training algorithms that analyze market data and predict stock price movements, enabling them to buy or sell stocks at opportune moments to maximize profits. Personalization, example, content recommendations, how it helps. Models analyze user preferences and behavior to deliver personalized recommendations. Everyday life example, streaming platforms like Netflix or Spotify use artificial intelligence models to analyze users' viewing or listening history and recommend content tailored to their tastes, enhancing user experience and engagement. Enhanced efficiency, example, supply chain management, how it helps. AI models optimize workflows and improve efficiency in various tasks. Everyday life example, retailers use artificial intelligence driven demand forecasting models to predict customer demand for products, optimizing inventory management and ensuring products are available when needed, thereby reducing stockouts and minimizing storage costs. In each of these examples, artificial intelligence models play a significant role in enhancing efficiency, enabling better decision making and providing personalized experiences, ultimately improving various aspects of human life and business operations. Define the problem. Example, predicting customer churn in a telecom company. Description, the problem is to predict whether a customer will churn, cancel their subscription based on various factors such as usage patterns, customer demographics, and service satisfaction. Objectives, reduce customer churn rate, identify factors influencing churn, and improve customer retention strategies. Data collection, example, customer churn prediction, data sources, customer demographics, call logs, internet usage data, customer service interactions, and satisfaction surveys, ensuring representativeness. Collect data from diverse customer segments to ensure the model captures patterns across different user groups. Data pre-processing, example, customer churn prediction, cleaning, remove duplicate entries, handle missing values, that is, impute with mean or median, and address outliers. Normalization scaling, scale numerical features, that is age, usage minutes, to a similar range to prevent bias towards certain features. Splitting data, divide the dataset into training, validation, and test sets, that is 70-15-15 split, to evaluate the model's performance effectively. Model selection, example, customer churn prediction, problem type, classification, predicting binary outcome, churn or not churn. Model options, decision trees, logistic regression, random forests, gradient boosting machines, GBM, selection criteria. Choose a model that balances accuracy, interpretability, and computational efficiency. Training, example, customer churn prediction algorithm. Train a random forest classifiers on the training data. Optimization, use techniques like gradient descent to optimize the model parameters and minimize prediction errors. Evaluation, example, customer churn prediction matrix. Evaluate the model's performance using metrics such as accuracy, precision, recall, and F1 score on the validation set. Hyperparameter tuning, adjust model hyperparameters, that is tree depth, number of trees, based on validation performance to improve model accuracy. Deployment, example, customer churn prediction integration. Integrate the trained model into the telecom company's CRM system to predict churn probability for individual customers. Real-time prediction. Implement mechanisms for real-time prediction of churn probability as new data becomes available. Monitoring and maintenance. Example, customer churn prediction. Performance monitoring. Monitor model performance in production to ensure it continues to provide accurate predictions over time. Retraining. Periodically retain the model with new data to adapt to changing customer behavior and prevent model degradation. By following these steps, data scientists and developers can effectively create, deploy, and maintain artificial intelligence models to address real world problems and contribute to business success. Each step is crucial in ensuring the model's effectiveness, accuracy, and relevance to the problem at hand.